Imagine, just for a second, that you're handed an incredibly complex problem. Maybe it's a massive, high-stakes project at work, or honestly, maybe it's just trying to plan your day when absolutely everything is going completely wrong. Oh, and here's the catch. You cannot use any of the normal tools you rely on. Sounds pretty stressful, right? Without a strategy, it absolutely is. But today, we're unpacking a universal, remarkably powerful problem-solving process that literally changes the game. Okay, let's dive into this explainer.
All right, here is our impossible real-world challenge. What is the sum of every single number between 1 and 200? Now, no calculator. How do you even start? Do you go, okay, 1 plus 2 is 3, then add 3 to get 6, then add 4 to get 10, carrying all those numbers in your head while you desperately scramble to remember where you even are? It's completely overwhelming. It's going to take forever, and without a plan, it genuinely feels like an impossible task.
Okay, let's take a deep breath and just slow right down. There is a much better way to do this. We're going to use a mentor framework known as computational thinking. Basically, this is the thought process involved in formulating a problem and expressing its solution so that a computer, a human, or a machine can actually carry it out effectively. Think of this as your absolute best friend right now, stepping in to offer some much-needed clarity and rescue us from all that math panic.
So this framework involves 4 distinct steps. Number 1, decomposition. 2, pattern recognition. 3, abstraction. And 4, algorithm design. This simple 4-step roadmap is going to turn our seemingly impossible math problem into a totally repeatable, easy-to-follow tutorial.
Step 1. Decomposition. This is simply breaking down complex problems into smaller, much more manageable parts. Before we even touch that math equation, how would you decompose a messy kitchen? Take a second to think about it. You wouldn't just blindly grab a sponge and start scrubbing randomly, right? You'd break it down. Load the dishes first, then wipe the counters, then finally sweep the floor. That right there? That's decomposition, and it is the crucial first move.
Now, applying this to our math problem, that frustrating, gonna-take-forever method is strictly chronological. 1 plus 2 is 3, 3 plus 4 is 7. It's a total nightmare to keep track of. But what if we decompose the problem strategically? What if we pair the absolute highest number with the absolute lowest? 200 plus 1 equals 201. 199 plus 2 equals 201. 198 plus 3 equals 201. See that? Suddenly, we're working so much smarter. Step 2, pattern recognition. Identifying patterns or trends within a problem. Now, what's really interesting about this slide is what starts to emerge when we look really closely at that smarter breakdown we just did.
Think about that number for a second. 201. Every single time we take the sum of the high number and the low number as we work our way inward, we hit a completely consistent pattern. Every single pair gives us the exact same sum, 201. Talk about a massive aha moment, right?
So instead of sitting there and counting every single pair one by one, which, let's be honest, would still take a really long time, we just need to figure out how many times that 201 pattern repeats. All we have to do is take our highest number, 200, and divide it by 2. 200 divided by 2 equals 100 pairs. Bam!
Which brings us to step 3, abstraction. Identifying specific similarities and differences to work toward a solution.
In plain English, abstraction means stripping away all the clutter so we can focus solely on the most important details. Since every pair gives us the exact same sum, we can get rid of the specific individual pairs altogether. We literally abstract them right out of the equation. It's exactly like ignoring that dirty kitchen floor so you can focus 100% on loading the dishwasher. We just focus on the core calculation now, the sum of the pair multiplied by the number of pairs. And when we multiply those two abstracted details together, 201 multiplied by 100 effortlessly gives us 20,100. No way, right? We literally just solved an impossible problem in a matter of seconds. Finally, step 4, algorithm design. Developing step-by-step instructions. This is where we build out instructions that we can actually use again to solve similar problems down the line. So, the crucial point is, we've just built an algorithm. Step 1, find the sum of the high number plus 1. Step 2, divide the high number by 2. Step 3, multiply the answers from Step 1 and Step 2 together. Just like your daily morning routine or your absolute favorite recipe, We have taken total chaos and transformed it into a super clean, universal formula.
All right, let's put our brand new algorithm to the test. Let's erase the 200s completely. What is the sum of all numbers between 1 and 1,000? Now, without our framework, a number that large is honestly terrifying. But with our algorithm, it's nothing to worry about. We've totally got this.
Let's run the steps real quick. Step 1. 1,000 plus 1 equals 1,001. Step 2. 1,000 divided by 2 equals 500. Step 3. We multiply step 1 by step 2. So 1,001 times 500. Notice how seamlessly our algorithm handles that massive scale.
The answer is 500,500. And this brilliantly illustrates the sheer power of computational thinking. What started out feeling like a tedious, completely impossible manual counting task was just solved confidently in 3 straightforward steps.
So let's lock this in. The 4 steps are 1. Decomposition, 2. Pattern recognition, 3. Abstraction, and 4. Algorithm design. Look, computational thinking isn't just some neat math trick. In modern workplace problem solving, these are the exact skills that allow teams to take a massive, overwhelming project, like launching a new app or totally restructuring a department, break it apart, find the trends, ignore the noise, and build a repeatable workflow. It is a wildly powerful structural skill you'll use for life.
Which leaves us with just one final thought for you to carry forward today. Whether you're staring down a messy kitchen, a sprawling data set at the office, or some seemingly impossible equation, with this incredible framework now firmly in your back pocket, what impossible problem will you break down next?